A is always positive. A and B aren't both 0, because then it would just be 0 equals 0 and would have an equation. There's a GCFs, they're all taken out and all that. There's just little things that occur. What's nice about standard form, I'm not going to ever make you take point slope form or slope intercept form and throw it into standard form. Because if you're at point slope form, you're basically one step away from slope intercept. And there's a button on your calculator that says y equals. So there's no reason to do that. When we're in standard form, we can do something like this. If I have 2x minus, trying to make this a little bit more difficult, minus 3y is 8. What's nice about standard form is that we can do what are called quick graphs. Ever heard of that before? That's a negative. So when we have quick graphs, what was it, 2x minus 3y is 8? Is that what I wrote? Okay. When we have what are called quick graphs, what we can do are basically graph these via their intercepts. Here's what I mean. What's the value of y, or excuse me, of x when I cross the y-axis? 0. What's the value of y when I cross the x-axis? 0. So if I cover up my y value, as in I'm making y equal to 0, what's my x-intercept for this equation?
Students and teachers, please excuse this interruption. This is a drill.
When you're working with this style problem, we're doing what are called quick graphs. We're covering and solving. We're going to graph via their intercepts. So in this one here, if I cover it,
are you going to leave the vest on?
might as well. It matches very nicely.
Oh yeah, just like your tie.
It's like twisted right here, and it's bothering me a lot.
It bothers me. So you have to undo it and then you twist it. Yeah.
There you go.
Okay,
There we
All right. So if I cover that up, what's my x-intercept?
4.
4. So my x-intercept is at 4.
I just talked.
Where's my y-intercept?
Like 1.6.
I don't do decimals. Would it be 8 over 3? Negative 8 over 3?
Yeah.
Which means that's a little bit less than negative 3, or a little bit more than negative 3, excuse me. So about here-ish. How many points do you need to create a line?
2.
And you're graphed.
2 points. Wow.
That's the advantage of standard form. I will not make you go from, so the questions that are on there that says rewrite into standard form, that's just stupid. Starting in standard form is great, but to go into standard form, it's just a waste of time. Because if you're already in slope intercept form or even point slope form, it's quicker. All right? So that's one of these things, there's a lot of little nuances that are in this book that I'm still finding out about and still looking at that aren't great, but we're getting there. All right. Another thing we have is we have our first contestant for your super awesome sign your autograph, Miss Fleming. What? You're not embarrassed though, right? Don't spell your name wrong. People forget how to spell their name when they're up.
Sarah, give me some autographs.
Because cursive is one straight line.
So you get to be the first to hang it for the year. So congratulations, you're so super cool. I wish I was as cool as you. What's this, number 11?
Sadie.
My signature is different every time, so mine's
Thank you.
It's really hard for me to go keep trying to verify your signature. Well, I'll look at your driver's license, but it's nothing like your insurance papers. It's unfortunate.
Do you know where the FTL is out here? All right, if you go out there, there's a printer.
Wow.
Will you go grab it off the printer?
dude, I should use that strategy.
And then you can hang it on the wall.
I know.
All right, a couple other quick things about this then that are in this unit is that we have what is called direct variation. And in this one here, It is silly, silly simple. There's only a couple quick questions that are in it. This actually deals with, it's kind of like a precursor to slope. I know that a lot of times algebra classes used to teach this method as far as how you worry about this, what's called direct variation. Now, there are little push pins and stuff on the back wall. I don't know, can you reach it? It's a joke. If you ask Hannah, she's tall, she might be able to help you out. It's a very exciting moment. Usually if you use two, then you can hold on both sides. See, she's good people, that Hannah. You're not embarrassed yet or anything, right? No. Okay. See, look at that. Thanks, Hannah. You're the best. Those are hard to push.
They are actually.
Cork is one of the strongest materials known to man.
What do we use that to the magical type that we created?
You're right. We use the magical cork and the pyramid of death along with our tarp of life.
Pyramid of death. That's my favorite. I want
Cake or death? Cake, please. It's not. I'm done. I'm done.
Same.
All right. Direct variation. Y equals some k value times x. This k value is called the constant of variation. This is basically slope-intercept form with a y-intercept of 0 and a slope that looks like the letter k. What happens here is that it'll say, find the value of k when x is -2 and y is 8. Then solve, for y when x is 7. It's a weird style problem for just basically figuring out some value k. What you're doing is you're using a one-step equation and then just resubstituting in. Okay? Later on, second semester, before we start talking about a lot of inverse properties and things like that, we will start talking about what's called joint variations, inverse variations, variation with different degrees and stuff. And it's a matter of being able to utilize this value k along with other numbers as well. It's nothing more than plug and chug. It really is. There's really nothing else fancy to it. So here we have a generic equation, y equals k times x. We know that x is -2, and then you get a y value of 8. So which variable are we solving for? Okay. So we have 8 equals -2 times something. What's the something? You're right, it's k. But k equals -4. Very good. So now I have this k value of -4, and I have an x value of 7. Therefore, y would equal, that's it. That's all you're doing. You're using substitution. Then
Wait,
that
don't
was
switch. No.
not switching. And that's all you're doing. You're solving for that value of k, reusing it to solve for y. That's all. There's really nothing crazy to it besides that. Okay? You don't believe me? Later on, I'll say, oh, that's all there is. Then you'll be like, well, wait, there's more. So I got a couple of graphs to work on with you guys. And when we do graphs, it's hole punch because there is some person that I know that may be standing rather close to me right now that would complain a lot
It was me.
if things weren't hole punched. Do you like it?
Yes, I do.
Stop.
Does it take all
Yes.
night? I do.
It's literally a huge stack.
I was sending you my notes. I was sending you my notes.
Ricocheted and it came over here.
Oh, no, don't get your notes out there. Don't use
That's how much you make graphs, huh? What do they do?
We have 20
Real fast, let's go through. Guys, let's go through real quick some graphing and shading problems with inequalities. What I'm going to be looking at here is we've got a couple of inequality problems to look at. I'm also going to walk you through an absolute value graph. As we get into the latter parts of chapter 3, actually starting in 3-4, I want to believe, we actually will graph some more inequalities via absolute value, and we'll be graphing a lot more inequalities in terms of systems. So just a quick little refresher on how you graph inequalities and also absolute values. So whenever you have an inequality graph, basically you're starting it out the same way as you would any other. Make sure you get it to slope-intercept form and then just go for it. So this one here, we've got y is less than or equal to 2x minus 5. It's in slope-intercept form. I have a slope of 2 and a y-intercept of, so where do you start your graph? -5, very good. So if I start my graph at -5, and we walk our slope up 2 over 1, and so on and so forth. Huh? Sorry, it was a little fuzzy when the copiers aren't very good. Now, let me ask you or show you a couple things. First of all, when I do these types of graphs, I like to over-graph the problem. I like to extend it all the way through the entire 10 by 10 grid that I use, and then go from there. Now, if you recall when you did these types of graphs, you had to ask yourself a question right off the bat. Is this one going to be a solid or a dotted line? Remember that?
Yep.
What is it going to be? And why is it solid? Because the equal. Okay. If this was just a dotted line, I could almost get away with the way it looks like right now, don't I? And that's the nice thing about graphing them like this. So we just connect the dots, la 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 la. And now we have cut our graph into what are called two half planes. Remember from geometry you had a plane was a flat surface extended in all directions? An XY coordinate grid is in and of itself the XY plane, coordinate plane. So what we've done is we've cut it in half, but we have to know what side to shade. Okay? So think back to when you did old-fashioned number line shading. You would plot the number line, you'd put that number in the middle, and you'd pick numbers on either side, preferably easy ones, 0 and 5. You would do the same thing. You would circle the number in the middle, and you would ask, is it a solid or is it an open dot? This one's open because it's just greater than. And then you would test it. Is 0 greater than 3? No. Is 5 greater than 3? Yes. So you always shaded towards the truth. The only thing that changes here, instead of being a single variable, it's 2 variable. So where can you find an ordered pair that is really, really, really easy to work with? 0, 0. Always try to use the origin when your test points for no matter what we do. We're going to graph inequalities in linear, quadratic, a whole bunch of different stuff. And anytime your line or your curve doesn't go through the origin, always use the origin as your test point because it's easy. So I test it. What happens here at 0, 0? Is 0 smaller than 2 times 0 minus 5? Is 0 smaller than negative 5? True or false? False. So this side is false, which means this side has to be true. And you shade towards the truth. And that's how you shade these types of things for me. Just a couple of slash lines through it, nothing too fancy. You don't have to overcolor it, because eventually we're going to be looking at overlaps. We're going to figure out feasible regions. We're going to find maximum values and stuff like that. So you don't want to try to over shade so that we can see where things are intersecting. Okay? Does that vaguely ring a bell?
Yeah. Very, very vaguely.
Yeah. It's just a matter of getting used to it again. Okay? It's just a matter of getting used to it. Let's see. Absolute value. We talked about absolute values before, right?
Yep.
Absolute value is the distance away something is from 0. Can absolute values ever be negative?
No.
Because can your tape measure measure negative distances?
No.
Can you take mileage off of your car going in reverse?
No.
Same idea. So real quick, let's just show a generic version of this in our calculator. Let me show you guys how to graph an absolute value in here first before we go through the rest. I got it for you, Lori. Yeah. So basically, I just need one color calculator then, right? I just need one for you. I just got to sign it out. Give me a second. If you want to use it for now, I'll sign out your name. Actually, you know what? Do me a favor. Write down that number. Give me the piece of paper. I guess you can I believe it is under Alpha Window. No, Alpha Zoom.
No, it's under the functions first.
Oh, there it was. Alpha Window number 1. Sorry. Alpha Window 1. There's a shortcut key for it, or you can go through it and find it under where it says Math, and then go through there. Yours should still do the same thing if you hit the Alpha Window. The operating system will be the same. It's just not in color. That's if you hit Alpha Window, it should jump right to it. That helps, yes. Hello, computer. Okay. So now hit Enter, and then just put an X in the middle.
How do you get, wait, what? Window.
Alpha Window 1.
Okay.
And then hit Graph.
I pressed alpha window 1 and it just came out with this thing.
Yeah.
I'm so bad.
I did it. I did it.
Okay.
All right, I'm sorry. I did not mention that since we're graphing, you want to be in the y equals table part first.
Yeah, you kind of need to go through every step.
Apparently.
I pick something.
So we get this graph. And basically what this is doing is that it's just taking your positive and your negative values of your absolute value, and it's just plotting them. Now, one thing I want to show you guys is that as certain values change, the lines themselves change. For example, back in your y equals table, see I told you where to go. Go to the second y sub 2, and let's put in 2 alpha window 1 x. And now look at the graph. You have 2 of them up there. What changed? Starts with an S and ends in an slope. The slope, very good. The slope changes. That's where you go for it.
Wait, how did you get the
I just went to the second y equals. See how there's multiple places to put multiple curves?
Why am I angles?
But he was making us mess.
Now, watch what happens for the. Let's go to the third one.
Which the reason why you guys pay extra for this calculator is so that we color.
What's that?
You guys pay extra for this not the right color.
Yeah, but you know what? Nowadays they're all $135. Each new one comes out, it's $135. They were $135 when I was in high school. Seriously, each new one, it starts at $135. Then the older models become like $99. Let's go to the third one. Let's do this. Negative alpha window and graph it. Gee, what happens if it's negative out in front of it? Exactly. Let's throw something inside it. Let's go to a fourth one. Let's do an alpha window 1. Let's do x plus 4 and graph it. Where'd that one go? It moved to the left. Okay. Yo!
My graph is super zoomed in and I don't know how to change it.
Hit the window button. Hit the window button and make your x min, x max at 10, negative 10, positive 10s. That's usually the quickest way to fix it. Okay. Let's do another one. Let's do alpha window 1, x plus 4. Get outside of the parentheses and let's subtract 5. We're moving it around. Down. Here's what's happening. You have what's called the generic form of an absolute value graph. Y equals A, absolute value x minus h plus k.
You can write that one now.
This is the generic form of absolute value.
Never mind.
It's a very easy thing to work with. Where the ordered pair, h, k, is, we'll call it the vertex. It's where it changes, where the v meets the minimum or the maximum value, if you will, the vertex. And this value of a is the slope. Now, this h and k is going to be a little bit something new to you guys. H stands for horizontal shift. H moves left and right, moves your x's. Horizontal, H, get it? K is vertical. It moves up and down. Yes, I know there's no K in it, but it sounds like it. So it's vertical, so it moves your y values. So if you have a generic equation that is in this standard form, let's say we have y equals 1/2 absolute value of x minus 4 plus 2. Where's my vertex going to be at?
Negative 4, 2.
4, 2, very good. My vertex would be at 4, 2, and what's my slope? 1/2. So what I would do if I'm graphing this guy by hand, what was it? 1/2. I know my vertex, bless you, is at 4, 2. I start this at 4, 2. The slope is positive. So from here, I'm going to go up 1 over 2, up 1 over 2. But I need to do the opposite way also. So I'm going to go up 1, left 2. And I get this. And that's how we graph it. If it's negative, it just means it's going down. That's it. That h and k value, you're going to see h is, well, basically, you're going to see a, h, and k in just about every single function that we graph, or even non-functions, really. You're going to see it all the time. And the a stands for that slope, amplitude, extra height where things rotate themselves through. The h and the k will always stand for horizontal and vertical shift. It's pretty straightforward, okay? I know that the drill kind of ate up a whole whopping 8 minutes, but that's kind of really all I had for this anyway. I know we'll with you guys, we'll do a couple extra of them tomorrow also, but all I want you to do tonight was the last bit. Let's see, we stopped at 20 yesterday, correct?
Yeah.
So add on these last, 7 problems I'm going to have here. I want you to do 22 through 30. Yeah. Yeah, it'll be 22, it's just one direct variation problem, and then through 30, don't rewrite into standard form. Don't rewrite into standard form, just leave it as slope-intercept form, okay? And then here with the graphing of the inequalities and stuff, when you graph an inequality that happens to be an absolute value, what rules do you think change? Nothing. None of those rules change. You graph it like you would normally with that AH and K method, and then you pick a point not on the line. If we start with that one tomorrow, we'll start with that one, because that's kind of where we finished up with the other classes. Just want to make sure you guys had a chance to be able to see where it's all at. Yeah. Yeah. What's that? No, I want you to do all of them. I just want you to go 20 through the 30, because I want you to practice just writing equations. These writing equations, slope intercept form, these will take you 2 seconds. They give you a slope and a y-intercept. So just work on the, basically what's going to take the longest is the graphing. I gave you graph paper, so that's good. Just continue with that graph paper. You look like you're upset. You okay, Oppenworth?
It's just my face.
Oh, upset face?
This is just.
All right.
Oh, yes.
Thanks for helping.
When it's 6:15, everyone must be like.
That's a lot.